Hey y'all, I wanted to show you how to work with algebraic fractions. Algebraic fractions are just like regular standard basic fractions, except you're going to have alphabets thrown in there. And that's all that means. So maybe it looks something like this, you know? Or it can look mm, like that. So basically you're going to get an alphabet in either the top part of the fraction, which is called the numerator, or you're going to get one in the bottom part, which is called the denominator. And it's just the alphabets. Here, like the parts of this fraction, right? If you have an alphabet right here, it's called a variable. Variable. If you see an alphabet, it's called a variable. If you see a number next to the alphabet, it has to be next to it. It has to be hanging out like a buddy. It's called a coefficient, right? So coefficient. Is that how you spell coefficient? I don't know. It's a number next to an alphabet. It's just the number part, so it would just be 4 in this example. A variable is just the alphabets. That's it. And if it's a number naked hanging out by itself, like this 7 and like this 3, it's called a constant. Because it's constantly the same, right? No matter what you do, it's always going to be a 3, it's always going to be a 7, it's always going to be like a 14 million. The variable part, the alphabets, you're supposed to throw random numbers in there, right? Depending on the directions of the question. So it switches up the whole thing. Like this 4x, I could put like a 3 in there and it changes up the answer to 12, right? So it changed, but you can't throw anything into that 3 of that constant. It's always going to be 3. So it's constantly a 3. So basically with these algebraic fractions, there's like 5 things I want to show you. I'm going to show you how to reduce them just to basically make the number smaller. And that's kind of interesting because what you're going to do is you're going to mess with the number part right here, and you're also going to mess with the alphabet part. So there's 2 parts to it. So it's not as straightforward as just like, hey, reduce it. It's a little bit of a couple of steps. Then we're going to multiply all of it together. So maybe it looks like this times like, I don't know, maybe like that, something like that. And then we're going to divide it. So we're going to have something like that. Multiplying and dividing, they're pretty similar in nature. I'll show you how it goes. Then we'll have adding and subtracting fractions where the bottom numbers are the same, and then when the bottom numbers are different. So these are different, but we also can get ones where they're the same, like maybe they both look like that. And I'll show you how to work on those as well. Hopefully the video won't be too long because I feel like, 5 different like little lessons. I think like hopefully it was not too long. Okay, cool. So we have coefficients, right? Because we decided those are called coefficients. If it's like a number next to an alphabet, it's called a coefficient. And then the alphabets themselves, they're called variables. Okay, now here's the thing with the coefficient variable thing. It's really not that important in algebraic fractions. But it helps to know those words because what's up is these words, it's never going to go away. You're going to keep hearing them over and over again, like in algebra and like calculus and trig and like linear. It's just never going to go away. So it's just good to know them. You know what I mean? Cool. So here's how we do it. We're going to work on the coefficients first, and then we're going to work on the variables. Okay, let's see. So we have 8 and 12. We're just reducing it. I'm just making it smaller. That's it. So they're both even numbers. So if you're not sure what number to like divide by, just keep dividing it by half. Just keep dividing it. Like, what is half of 8? It's a 4. What is half of 12? It's a 6. Now we have 4 over 6. We can keep going. I mean, just keep dividing by half if you're not sure. What is half of 4? Well, it gives me 2. What's half of 3? I'm sorry. What's half of 6? It is, in fact, 3. Sorry, I was jumping the gun. Or jumping the pew-pew. Sorry. Okay. So now I can't reduce it any further. I can't, like, divide any further because what's going to happen is I'll get a weird fraction. That 3 is going to become a 1.5, so I got to stop here, right? So now I know since I can't go any further, that's pretty much the answer. But you don't have to do that. You can just look at it and just go, okay, well, 6 is too big, 2 is probably too small. How about let's divide by 4, right? You can start guessing. And we can just go, oh, that's 2, and then that's 3, right? How many times does 4 go into 8? How many times does 4 go into 12? This is the answer. So you can also just essentially plug numbers in and just guess. This method, if you're not sure, this method is pretty good because you'll eventually end up with the correct answer. A couple of more steps, but if your goal is to basically get a really good grade, I would go the direction of just dividing by half over and over and over again. It's no big deal when it's small numbers, but man, when you're dealing with like 100, 150, 2,000, it gets crazy. So sometimes it's not always useful to just keep dividing, you know what I mean? By half. So, okay, what about the variables, the alphabets part? Let's just do the A's first, and then we'll do the B's next. What we're going to do is we're going to subtract. We're going to subtract the denominator by the numerator. So we're going to subtract the bottom number by the top number. So it's going to look like this. A3 minus A2. Right? So it's a cube and a square. What does that get me? Well, we have the same base. The base is the letter A. And now we got to figure out what goes up here. Well, 3 minus 2 is 1. So the answer is actually just A. So that's my answer. It's literally straight up A with that little invisible baby 1. What about B? Remember, we're doing bottom and top, right? We're doing bottom first, then the top. So I'm doing the denominator, which is B1, right? We'll just put that little invisible 1. Minus, right? B1. I have the same base, so I know it's going to be B. What is 1 minus 1? Well, it's 0. It's 0. Now, here's the thing. You could say this is the answer, but what's up is anytime you multiply an alphabet or a number to the power of 0, which is this exponent, it's straight up going to equal 1. Anytime you raise anything to the power of 0, it could be like x0, it could be 7-0, it could be 2x0, like that. It's always going to be 1. So the final answer is actually 1, right? This is a correct answer. This is technically right, but this is really the more sophisticated answer. Let's put it all together. So we had our coefficient and we had 2 variables. This is what we came up with, the coefficient. And the variable was an A. That goes in the bottom. There was no B because it became a 1. This is my final answer right here. Now, how did I know to put the A in the bottom? So whichever one is the bigger number, that's where it lives. So the 3 is bigger than that too. So it lives downstairs because the 3 happens to be bigger. Let's do another one where maybe I'm not so wordy so we can just see the streamlined process, because I wonder if the way I described that was not sufficient. So let's try it again. So we're just going to do the coefficient, right? The number part, and then we'll do the variable part. And we're going to do every single alphabet separately. So we're going to do X first and then Y second. How many times does 5 go into 10? It goes in twice. So we're going to change that 10 to a 2, and that 5 becomes a 1. Because how many times does 5 go into 5? It goes in 1 time. How many times does 5 go into 10? 2 times. What we're basically doing is this right here. I'm dividing it. Well, that gives me 1. 5 goes into 5 once, and then 5 goes into 10 twice. That's how I came up with that number, right? Okay, what about the x's? Remember, we're doing the bottom first, minus x1. Put that invisible little 1 there so you can keep track. The base is the same. 3 minus 2, what does that give me? I'm sorry, it's 3 minus 1. I'm just jumping the pew again. Okay, that's a 2. Cool, sweet. What about this one? This time, it looks kind of like we have to do the top part this time, right? Why are we doing it this way? Why am I doing the numerator, the top part this time? Because we're going to put the answer in the top part for y, right? Right here is the bigger one, right here is the bigger one. So for one of these, we're doing it in the top, and we're starting at the top. And then the other one, we're starting at the bottom. So this is where it kind of gets tricky, because it's like we were doing just the denominator earlier, Well, now we're doing the top part for y. And what is it? 3 minus 1 is 2. We have the same base, and it's 2. So where does this one go? It goes in the top, also known as the numerator. And this x1 goes in the bottom, also known as the denominator. How do I know that? Well, here's the x. It's bigger. The one in the top is a 1. That's why it's not going there. The y, it's bigger in the top. So it goes in the top. So let's go ahead and put it all together. What does that give me? The coefficients is right here. And then I have my, which one's that next? X. I have my x at the bottom here. Give me x squared. Let's do that invisible 1. And then I have my y, which would be y squared 1. If I were to put all these together, what's my answer? It gives me y squared over 2x squared. Right? That's my final answer right here. Another way you could set it up is you can even do something like this, which is pretty much like right here. This is also, like, I guess, technically all 3 of these is correct. Let's try more. Oh, here's a good one. This is a bunch of stuff crammed together. So what do we do here? Because, I mean, there's a lot of stuff going on. I have constants. These are constants. And then I have variables. And then I have coefficients. What do I do? Where do I start? Well, before you kind of like get nervous, just take a look at this thing. This whole entire fraction, we can factor it, right? Because we can try to go like, oh, well, maybe 8, and we can go and divide it by half. But the thing is, how do I keep dividing the 4 and the 5? I can't. And I can't do anything with x. I mean, it's not going to make sense, right? To just have like a bunch of numbers. So we're going to go ahead and factor. This is a good question because, or I guess like a good problem, because every single math problem we've done so far had a different little step to it that wasn't predictable until we came across it. So sometimes we're not allowed to go into like robot mode or anything, So what do I do? How about we take out like a 5? And then we're going to get a 5x plus 1. What about the other one? Maybe we can take out a 4. And that gives me maybe like a 2x plus 1, right? And, oh wait, this is a 2. Right? Because it's a 10. Ooh, I almost was going to do something really elaborate here. Okay, I'm glad I caught that. Great. Okay, so we factored. Now what do we do? Could this be the final answer? Not quite, not quite. What else can we do? Well, can I do anything with 5 and 4? Does 5 and 4 do anything? Can I divide it? I can't subtract it. That's not allowed. I could only do that with variables. Let's see. I guess I can't do anything with 5 and 4, so it has to stay as is. What about this? What about this whole entire thing in parentheses? Well, it's technically a variable. There's a variable in it, and it's in parentheses, so it means it's one whole problem. So basically, what it's saying is, what is this minus this? It's just 1, right? Because it's this 0, right? And anything risen to the power of 0, the entire whole guy becomes 1. So what does that give me? It gives me 5 over 4 times 1. Times 1. And what does that give me? 5 over 4. This is actually the final answer, because basically what happened is we crossed these out. They're the same thing, right? This is basically crossing things out. That's the answer. Now here's the thing. This is called an improper fraction. So if I have an improper fraction, I could turn it into a mixed number. I do 4 divided by 5 goes in one time, 4, subtraction, it gives me a remainder of 1. So I take the top number and I get this, right? So this is the final answer. This is also the final answer. Both of these are correct. Maybe we can do another one. Let's see. What do I do here? Kind of looks like there's not much options. There's no numbers. It's just variables. It's just alphabets. Well, we can do the factoring thing again. Except what we could do this time is, let's see. These are kind of set up in a way, I'm trying to explain. Let me see. These are set up in a way where it gives you hints. Like this is a little bit of a hint. And that's not going to make sense until you do a bunch of these problems. With the top one, I can't just like factor something. I can't just do like x, right? And then just do like x minus y or something. That doesn't work because there's only one x and there's only one y. I don't have repeating patterns. So what I can do is I could put an x here and an x here. And I could put a y here and a y here. And there's a minus sign. Every time there's a minus, it's understood the minus goes here and the plus goes here. I have a video that explains that. I forgot what it's called. I forgot the title though. So I'm not sure how useful that data was. Okay, and then we put the bottom one exactly as it is. So now I have this set up here, right? What do I do now? Well, I can cross things out. Is there any repeating patterns? This one and this one, that's repeating. We don't need those. What do I have left? Just that, just the top part, the numerator. That's it. That's our final answer. We just did a little bit of factoring and then we just crossed out similarities. That's all we did. Let's try another one. Let's see. This one looks like more stuff we can do. It looks like there's going to be more factoring stuff and maybe some foily stuff. Let's see. Maybe with the top one, there's two A's. When I mean there's two A's, I mean this is a term and this is a term. And both terms have repeating patterns. What that pattern is the letter A. So what I can do is I can factor out the A. I could do A plus 1, right? And what about this bottom part? Got to factor stuff there too. But here's the thing. I have that 2 up here, so it's going to be really, really tough to factor. How do I get rid of that 2? Because sometimes you can get rid of it. Well, I can factor out the 2. Because these are all like numbers that are comfortably going to hang out with 2. Right? So this will become 2a plus 1. Right? All I did is divide it by 2. Now I have this guy right here. Now what do I do? Well, I can factor the second part. So I'm going to keep the first part as is. The top part, rather. I'm going to keep that 2 there. Don't forget that he exists. And let's see. I have an A here, an A here. 1 and 1. Maybe I could do 1 here and 1 here. They're both positive because both of these terms are positive. So now I have this going. Now what do I do? Right? So I could get here. This is how it looks. Let me go ahead and show you. Because I wonder if those brackets are a little bit too much. A plus 1, A plus 1. That's what I have. These are both exact same thing right here. So what do I do now? Well, I could look for repeating patterns. There's an A in the numerator, the top part, but there's not like basically an A by itself in the bottom. I have a 2 in the bottom, but there's no 2's or anything at the top, so I can't do anything with that. I do have A plus 1. If it's in parentheses, it's like one single basic number. I can get rid of that and I can get rid of that because they're both the same. This one's the same too, but I don't have like a partner for it. It has to be like exactly identical. It has to have a partner. So what do I have left? I have an A in the numerator. Then I have a 2A plus 1. This is my final answer. So when you're reducing algebraic fractions, what you want to do is you want to take a look at the coefficient, which is the numbers in the front, Then you want to look at the next set of alphabets, which is like an A, a B, a C, an X, a Z, stuff like that. And sometimes when you can't think of what to do, just keep dividing by half every single time. Or get the whole factor thing going. Because if it's just like a bunch of weird, random, like alphabets and numbers like this, you're probably going to have to factor, you know? So get cool with factoring, you know what I mean? And I have a video on factoring if you're into that. But I mean, there's a bunch online. So let's see. Let's do multiplying next. So let's see. Multiplying is way, way, way easier. I feel like multiplying fractions, like regular fractions and also algebraic fractions, I feel like that's like the easiest game, like in town compared to like all the other stuff we're doing. So I feel like multiplying is going to be like super chill. So with multiplying, all you're doing is it's only with multiplication. You're just taking the top number, which is the numerator, and multiplying them together. And you're doing the exact same thing with the bottom numbers, which is called the denominator. So 6 times 2, what does that give me? It gives me 12x. And then I have 11 times 5, it gives me 55. And then I have that y, right? And then that's it. That's the answer. We're done, right? So, I mean, it's pretty chill. It's pretty straightforward. Let's try another one. So we're going to put these together, and we're going to put these together. Let's just do this top circle first. So what is 3 times 2? It gives me 6. I can't multiply a squared by anything because it's just a squared by itself, so just write it down by itself. What about b? I can't multiply that against anything, it's just b, so let's just write that down. What about the bottom part? 5 times 9 is 45, and then we have a and b again. So the thing is, I have b up front. You could do 45ba. You could do that. It's still technically correct. But the way these variable alphabet things work is you're supposed to put them alphabetical, ABC order. So a comes first. Let's see. So let's see, 6 and 45. I could reduce, I mean, this could technically be the answer, right? You can just say, hey, this is it. This is my final answer. I mean, you're right. But we can actually reduce. We can reduce the 6 and the 45. Let's see, 2, 3. We can divide it by 3, you know? Divided by 3, divided by 3. So how many times does 3 go into 6? It goes in 2 times. And how many times does it go into 45? It goes in 15 times. We keep the variables exactly as they are because there's nothing to do there. And let's see, what else can we do? That's correct. Now we're going to move on to the variables. And what is the game? We're going to do 2a minus a, which gives me a1. Another way to look at it is how many times does this go in, right? So it's just a, because we're subtracting. B and B disappear, so it gives me 2, 15a. Right? So this is technically correct. It's just not reduced. And then this is the reduced version of that. Right? So let's see. Is there anything else? No. That's it. Yeah, so these two are chill. Those are both correct answers. You can have multiple correct answers on one problem. I mean, it really depends on your like instructor. Some instructors are cool with that, but some aren't. Okay, cool. So now I have this next problem, and we're still multiplying. So, what do I do here? I could just multiply across, but we can also factor. 3, let's do x plus 1 over 6, right? So why is that useful? Because now I can cross these two out, right? And then what is 5 times 3? It's 15. And then the 6 is just by itself, just hanging out. This could be the answer, except we can reduce that. We can divide it by 3 again, and it gives me 5 over 2, right? That's improper. If an improper fraction is if the top part is really, really big and the bottom part is really, really small. And then we got to turn it into a mixed. So I do the bottom part over the top, times the top, divided by the top. I don't know what's happening today. Okay. How many times does 2 go into 5? It goes in twice. gives me a 4. Subtracting, remainder is going to be 1. So this is going to be the main answer. And then we have half. Right? So look, here's the thing. We have 3 answers. This is right. This is right. This is right. Straight up, all 3 of those are chill. Those are technically all correct. Right? It just depends on what your instructor wants. They might be cool, but they might not be with some of these. I've had instructors that were like okay with all of them, and then I had instructors that would just like completely spaz out on you and like give you bad grades and stuff. Like, I don't know, some people are bitter. All right, so let's see. Here's some more stuff. We can just multiply across. We could just multiply across. I could put like, see, the thing is it gets tough because you're multiplying here, you're multiplying here. So then you get 3x squared y minus 12y, and then you come over here, and then you have this and this. Do you see how it's getting really, really elaborate? So sometimes it's better not to do that, because now we get like 12x plus 24x, and now here's the thing. I got to factor this, and I got to factor this. So then you got to do like a thing where you're like, okay, how do I get x and y alone? And then I got to figure out how to reduce that. It gets tricky. What you could do, I mean, it will work. You'll get the right answer, by the way. What you could do is you could factor from the beginning before you even start putting things together. So what could I factor? Well, I could factor this and I can factor that. Meaning, I'm going to do like, here's the first part, right? We'll call this star. This is star, and then this is heart. Okay, so we have x, and then that's a minus. So we can, every time there's a minus, it's understood it looks like that. And again, there's a video that shows you how, right? So this is star. We have star figured out. We're going to do times, and now we're going to do the heart one. And we're factoring this bottom part now. So I'm going to leave 3y as it is, and then we're going to factor, we can just put a 2, factor out the 2, plus 2. Right? Do you see how I kind of just pulled something out? And with the other one, I straight up factored. Now what? What do I do? Well, we can go across, right? We can find stuff similar here. We can find stuff similar here. And there is stuff similar. This and this get crossed out, which is pretty exciting. So let's see. And I can even cross out these. How many times does 3 get divided by 3? 1. And then 6 divided by 3, that's a 2. So now I can multiply. What do I have? I have x minus 2, and then I have 2 times 2. What does that give me? Wait, I think there's a y here. Yeah, there's a y. There's a y here, and then there's x minus 2. Well, what does that give me? Let's move it here. Well, I have x minus 2, y, and then 2 times 2 is 4, right? So this is my final answer. I can also move the y to the front. That's what I personally do. It's the exact same answer. I just moved it to the front. Both of these are correct. These are both the final answer. So the original method where I was distributing the 3y and then distributing the 6, you can do that method as well, but you'll have to factor stuff out. And then you basically do what I just did, which is trying to see all the like terms and getting rid of them. You'll basically end up, if you were to do that factoring method, I mean distribution and factoring, you'll end up right here. It just saves you a step to do it from the jump instead of like doing it later, if that makes sense. Here's a really elaborate one. So anytime you see something elaborate like here and here, it's going to be understood you got to factor. So let's go ahead and do that. Okay, so with this first part right here, it's going to be x with those pluses. Okay, I'm going to do like 2 and then x2. I have x minus 3. I mean, you can always like pause if that makes sense and work it out. I don't know if I'm going like rapidly. Okay, let's see. I'm going to factor out a 3. X plus 2. Cool. Let's see. Now we can get rid of this and we can get rid of this, which is nice. And then what do I have left? I have x plus 2 times 5. And then the bottom part, I have x minus 3 times 3. Right? So this is the final answer. We can't do anything else. I like to put the numbers up front. It's a little bit more clean, in my opinion. There we go. Those are both cool. They're both the exact same answer. So with multiplying algebraic fractions, all you're doing is you're taking the top numbers and putting them together and the bottom numbers and putting them together. With algebraic stuff, there's going to be a high opportunity. There's a high chance you're going to have to factor. So you've got to get comfortable with factoring. This thing with factoring is it's never going to leave your side if you're going to do math in any format. In algebra and in trig and in calculus, you're going to have to learn how to factor. We can't get rid of it. So I think I'm pretty sure I have a video on factoring. All right, we're going to move into division. Division's pretty chill. I know it looks intimidating, but it's pretty chill. It's so close to multiplying. So it's not going to be too tricky. I'll show you how to do it. Okay, when you get a division problem like this, all you're doing is you're taking the second term and you're flipping it. And then you're going to multiply. That's it. 8x3, 15, times 3 over 6x to the second. All I did is flip the second fraction or term, and then I changed it to multiplication. That's it. That's all I did. And then what I did is I put it together, right? I put these together, and then I put these together. So let's see. The term, I mean, if you're wondering, the flipping thing, it's called inversing the fraction or inverse of the fraction, right? Because we're inverting it. We're inverting this right here. So let's see. That's going to give me 24 x to the third over, let me get this calculator thing going because I'm not sure, 90 x to the second. Cool. Now look, here's the thing. This is technically the answer, but you have to reduce. You might not be able to see that right away, 24 and 90. Just play around with the calculator, play around with some math and see, does it look like it? If it's even numbers on the ends, yeah, we can reduce. So that's kind of how you know that we can reduce. What number do I reduce it by? Do I do a 3, a 10, a 7, a 2? That gets tricky, right? And if you're never sure, just keep dividing by 2. Keep dividing. Just keep dividing everything by half, 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 half. And you might land on the right number, right? So let's see. With this one, let's try 6. How many times does 6 go into 24? Well, it goes in 4 times. What about, let's do the variable. Let's bring it with us. What about 90? How many times? Actually, I don't know. Let me take a look. 15. It goes in 15 times. Cool. Perfect. Okay. So, I got the coefficients taken care of, the number parts. Now I got to do the variable. I'm going to do this setup right here, right? Or I'm just basically going to subtract here. That's a 1, and that just gives me an x. Same idea here. Same base, it gives me a 1. Where does this live? Well, it lives wherever the biggest number was, right? Because we changed the numbers up. So what does that give me as my final answer? Well, we keep the 4 and the 15. The bottom part has basically that 1. We're not going to mess with that. And then the top part is an x. There we go. That's the final answer. Both of these are correct. They can both be the answer. This is the reduced version. This is the original version. And again, it's whatever your instructor is cool with. Honestly, I'm going to be real with you. Your instructor is going to want the reduced one. There's a high probability that that's what your instructor wants, no matter who your instructor is. Okay. Here's another one. This one looks a little bit tricky. What do? Anytime you have a whole number against a fraction, no matter what you're doing, adding, subtracting, multiplying, dividing, you're going to take the whole number and you're going to put an invisible little 1 underneath it. So basically, it becomes a fraction, right? Now it's not so weird looking anymore. It's just like what we've been messing with this whole time. But it's division, so what do? I do the inverse, which means I take the second part, only the second part, and I flip it and I turn it into multiplication. What does that look like? It looks like this. Multiplying 1 over, right? It looks like that. And basically, I had to develop that 1. I had to create it by just shoving a little 1 underneath, and then I flipped it. Now I just go ahead and I could multiply across, right? We can just multiply across. Let's try that. It basically gives me this right here. And then let's see, is there any like terms? Yeah, certainly. We get rid of those. So now I have 1 over 5. It's not just 5, it's 1 over 5. Because it was a fraction originally, I got to keep it a fraction. Because it's understood that there's little invisible 1 here. So when I got rid of those, it was 1 over 5, right? So that's my final answer. But you don't have to just multiply across. You can take a look and see, is there any like terms, right? Right up here. Well, yeah, there is. These guys right here, I can get rid of those. And what does it leave me with? It leaves me with 1 over 5. Right? So there's different steps that you can use to solve this. Both gave me the exact same answer. One of them I multiplied across, and the other one I just looked for like terms. I never multiplied across. And I got the same exact correct answer. Both ways I went. Right? So there's a lot of flexibility in math. Sometimes it doesn't feel like it. Let's see. What do we do here? It's a bunch of random stuff, a bunch of random fractions and variables and constants, coefficients. Well, we're doing division, so what do? Inverse, which means I take the first, I keep it exactly as it is, multiply, and I flip. I flip the second guy. Perfect. Now what do? Well, I multiply across. Here's the thing, I can't divide I can't remove stuff. I can't remove stuff like with here and here because I can only do that with multiplication. I can do that with this. I could do that with here. That gives me a 1 and that gives me a 2. So then I have 2x plus 6 times 2. And then I have x plus 3. Actually, that gets us in some trouble. Let's not do that. Where's my... What was that? It was a 5, and then it was a 10 up here. Okay, let's go ahead and multiply it together. What does it give me? It gives me 10, 2x plus 6 over 5x plus 3. Yeah, this is way, way, way better. Okay, what do I do now? Well, I can factor this out. 10, 2, what would that be? It would be an x plus a 3. And then, yeah, we'll keep that as it is. X plus 3. Great. What does that give me? Well, I can get rid of these. I can get rid of these, so it gives me 10 times 2 over 5. And what does that give me? It gives me 20 over 5, because I multiplied these two together. Well, I mean, I could keep it this answer, but we can keep reducing. How many times does 5 go into 20? It goes in 4 times, so it gives me a whole number as my final answer. This is straight up the final answer. I mean, I guess this could technically be, but there's an expectation to know that it's a 4. Great. Okay, that could have been a disaster. Because then we'd have to do all this extra elaborate. Okay. Here's another one. Okay, what do we do here? Well, just flip this guy. Actually, you know what? I should make it smaller. 5x plus 6 times x plus 3 over x. Okay, cool. When you do a bunch of these problems, you can see I got to factor this, and it's most likely going to match that, right? So let's go ahead and factor it. What would it look like? It would be, let's keep the top number as it is. X, I want to spread that a little bit more. X, 6, yeah, let's do 2, and then 3. Plus x plus 3 over x. Yeah, cool. Let's see, we can get rid of these, which would make it x squared over x plus 2. Let's see, that becomes 1. That becomes x, which gives us x plus 2. That's our final answer. Yeah. So basically, what you do is, I essentially just saw patterns, right? It wasn't really like a logical thing I did. It was just I was able to see patterns because I've done so many of these problems just now with you guys, right? We did like 10 problems or something. We were able to predict they're probably going to ask us to factor that, right? So, and you'll be able to do that too. You'll be able to see, like, you can kind of guess what they're asking, if that makes sense. Let's see. With division, all you do is find the inverse of it, which is flipping the second fraction and then turning it into multiplication. Sometimes you got to factor, sometimes you can just go all the way across and multiply. What about algebraic fractions with the same bottom number? How do I do that? Those are super easy too, because all you're doing is literally adding. If the denominator is the same, you basically did have 50% of the work already. So what do? If the base is the same, you keep it the same. It's similar to something called the boots and hat method. There's a video on that on my channel. What's 3 plus 2? It's 5. That's it. That's the final answer. You just keep the base, which is the bottom number, the same. And then you just do whatever the top part is telling you to do, right? With the operator. The operator thing is the plus sign. Let's see if there's something else. Sometimes it gets a little bit tricky. Like this one. What do I do here? Well, we're going to do x minus 1 plus right here, 3x plus 2. The bottom is going to be a y. Now what do? I have all this stuff up here. Do I factor? Not exactly. We don't factor. We're just going to find all the like terms. I have x plus 3x. What does that give me? It gives me 4x. What about negative 1 plus 2? What does that give me? It gives me 1. It gives me positive 1. Why? This is the final answer. I can't factor any further. I can't like remove the 4 or the 1 or anything. So there's no like multiple answers that are the same. It's just this guy. Okay, what about this one? See, here's a really good one. Keep in mind it's a subtraction. So what does that look like? It looks like 4x minus 3 minus 3x minus 3 over x. Okay, what do I do now? No more factoring. We're not factoring. We're going to distribute that 1. I mean, it's that negative. We're going to distribute that negative 1. I guess that's like an invisible. I probably should have just said negative. What does that look like? 4x minus 3 minus 3x, and it's going to be plus 3, right? Two negatives make a positive. X. What does that give us? 4 minus 3 gives us x. Negative 3 minus 3 gives us a 0. So it's actually x over x. And how many times does x go into x? 1 time. That's our final answer right there. Sometimes it's like a really interesting, clean answer. What about here? Same denominator. Well, let's go ahead and do exactly what we just did. 6x minus 3 minus x plus 2. With the same base, we're going to distribute that negative. What does that give me? 6x minus 3 minus x minus 2 all over x minus 4. I have the same base. So I have 6 minus 1. That gives me 5x. Right? And what about negative 3 minus 2? What does that give me? Gives me negative 5. And what, does it give me negative 5? Negative 3 minus 2. Let me see. Yeah, it gives me negative 5. Why does it feel like it's not? Okay, cool. It gives me negative 5. Right? This is my final answer. Here's the thing. In that numerator, the top part, it kind of looks like I can factor something out. So let me try that. Let's see. X minus 1. X minus 4. These are both correct. Right? So we have two final answers that can totally be chill. I guess it depends on what your instructor wants. But both are right, both are correct. So when you are adding or subtracting algebraic fractions, and they're the same bottom number, I'm talking exactly the same. Like, I'm talking they're twins, right? All you do is just work on the top part, because the bottom part, it's understood. That work has already been done. But here's what's up. What if they're different? Because like the whole game changes, man. Now you got to do something elaborate. And it's not always too elaborate. It really just depends. So let's see. All we're doing is we're going to have to figure out how to make it the same on the bottom. What does that look like? We're just going to figure out how to get a y into that guy and how to get an x into that guy. And that's it. That's all we're doing. It's basic algebra. That means it's basic fractions like you've been doing. I have a video on this, by the way, in my channel, if you're like into that. Okay, so what does that look like? It's going to look like, should I get like different colors going? Maybe like a yellow. Okay, so I have 2 over x, and then I have 3 over y. Let's see. Okay, I'm going to make it y over here. We're going to do times. Well, let me space that out a little bit. We're multiplying y, right? And then over here, we're multiplying x. Right, we had a plus sign right here. So I just took the whole, everything in yellow is the original problem, and everything in blue is what I'm putting in as like a person trying to make the bottom parts the same. So that's what it's going to look like, basically like that, see? And whatever I do to the bottom, I have to do to the top in the exact same way. So if I was multiplying like a 7 in the bottom, I got to put a 7 in the top, right? So what does this give me? So if I just put all these together, basically, what does 2 times y give me? It gives me 2y. And then the bottom gives me xy plus, because that's what it told me to do. And I did that right here, and I'm going to showcase it right here. It's 3x with the same base, which is x and y. Great. Now, I have this right here, which is what we were doing earlier, which was the exact same bottom part. So if it's the exact same bottom part, all I do is mess with the top. So we're doing the bottom part. What is the top? Well, it's going to be 3y plus 3x. I can't do very much with it, right? So this is my final answer right here. I joined them all together. I added these together. And then the base is just going to be one representation of all of them, right? Similar to what I call the Boot Hat method, which I do have a video. Cool. So this is the final answer. There's only one final answer this time. Let's try more stuff. Okay, different bases, super bummer. We got to figure out how to make them the same. So 4y, then we have, it's 4 and then x and 4 is what we have. And then I have 3. Actually, it's a subtraction, so let's go ahead and fix that up. Subtraction. So what do? Well, I feel like I should get another pen. I feel like the whole different pen method is useful for us. Okay, so this is what it looks like, right? Oh no. This is way too far away. Okay, what was it? It was y minus 3. Okay, let me get my yellow pen back. Okay, cool. We have to multiply. Remember, we got to multiply. So what do I multiply? I got to make the bottoms the same. That's my goal. Okay, so I'm going to put a 3 here. See, I was inspired to put that there. That's where I got that 3. I'm going to put a 4 here. Whatever I do to the bottom, I got to do to the top. Now, did you notice that the 4 has an X above it, but I didn't do that. I didn't put an X anywhere in the yellow font. I only put the numbers there because whatever I do in the bottom, I got to repeat at the top. Right? So I'm not repeating the entire fraction that was given to me. I'm just repeating what I'm doing in the bottom to make the bottoms match. Great. So what does that give me? Let's go ahead and put them together. I have X and 3, and then I have 12 in the bottom. And then I have the negative sign because it gave me negative, and then I have that Y and that 4, right? And I got 12. Great. So I have the same base. I'm going to rewrite it because it kind of looks messy. So let's go ahead and rewrite it. I'm going to do 3x 12 minus 4y 12. See, it looks a little bit more familiar. So now what do? I just mess with the top, which would be 3x minus 4y. And then we have one base to represent all of them. And that's it. That's my final answer. Right? I can't do much with x and y, so I can't like add them together, subtract them, or do factoring or anything. I basically just have to keep it as is. So it feels like there's a whole math problem on top where the numerator is. But it's the correct answer. Here's another one. This is a good one. I like this one. Let's go ahead and set it up like we've been doing. Y plus 5 over 2y, right? It's a plus sign. We have y minus 2, 8y. Let's do red. Let's see. What do? Well, I gotta multiply. We have a y already, so we don't gotta add a y. Now here's the thing. I could do something like maybe 8y here, and then I could do like a 2y here. But that's really, really big. We don't necessarily need to. I mean, you could do that, but we don't necessarily need to, because now what happens is, if you just throw in any number and it's really super big, you'd have to eventually reduce, and you've unknowingly gave yourself an extra step. And here's the thing, man, you might reduce, and then what if you reduce wrong? What if there's way more to reduce and you thought you were done reducing, and now you lose points, but every other step was totally chill, you got everything else right. And then you lose points you didn't deserve to lose. So it gets tricky. So what we're going to do is, instead of just throwing the 8y on one side and the 2y on the other side, what we're going to do is, we're going to figure out a way to get both of them to be 8y. How do I do that? Well, I could put a 4 here. Just here, and whatever I do at the bottom, I got to do at the top. I'm going to keep the other guy exactly as it is. Let's just do a 1. Now let's go ahead and multiply everything together. What does that give me? It gives me 4y plus 5 over 8y, right? Because 2 times 4 is 8, plus y minus 2, right? Because if you multiply that by 1, it gives you the exact same number, and we're going to keep that 8y. I basically left the second part untouched is what I did, right? So what does that give me? Well, before I start putting these together, I have to look really carefully. I have to put that 4 and distribute it. It gives me 4y plus 20. 8y plus 4. That's not a 4, that's a y. Y minus 2. 8y. Right? So now we're going to put these together. What does that give me? It gives me 4y plus 20 plus y minus 2 all over 8y. And now we're going to put the y's together, which is 5y. And then 20 minus 2 is 18, which is plus 18, 8y. This is my final answer. I can't factor this part out, right? Because it's a 5 and an 18. If it was like a 6y plus 18, then yeah, I could start pulling things out, but I can't pull anything out. So that's my final answer. So what we did is we had just one part that was being multiplied by something, just one term, not the second term. And then I distributed. I didn't expect to do that, right? And then we did the whole traditional thing we do, which is we add everything together and then we see all the like terms. And then we got our final answer. Kind of fun. Hooray. Let's try another one. Okay, same idea. Let's see, same concept. So let's go ahead and set it up, right? If you're never sure, just set it up like this, right? Where you're leaving space for this anticipation of adding more stuff. So now I have x and x cube. What do I do? Well, I gotta make it x cube on one side, and the other guy, he's cool. X cube is cool. We can keep him x cube. We can make everything look x cube, so I just mess with one side. What does that look like? Well, I could multiply x squared. X squared, right? I can leave this exactly as it is, right? Untouched, basically. I'm doing a 1 as a placeholder, but essentially it's untouched. We're not even going to mess with it, right? It just looks like that. What does that give me? Well, it gives me 7x second x cube, right? This is cubed, plus 3x cube. Great. Now we got the same base. Hooray. Let's go ahead and put these together. What would that be? It would be 7x squared plus 3. We're not multiplying, right? That's why we didn't add it together. It's not 21. This is my final answer. I can't factor anything out. I can't think of anything that would I can't think of anything that would go together. That's my final answer. Let's do more. This one looks kind of tricky, right? Right here, these almost look alike, but they're not. They're not alike. So we gotta go ahead and do the same method that we were implementing. I'm going to multiply against a mystery number we don't know yet. And then I'm going to rewrite what they gave me here against a mystery number that we don't know yet. Let's see, what can we add on there? So I got 2x on one part and I got 2y's on the other part. So we can just even it out. We can just put a y here. We can just put an x here. Right? So what would that look like? I'm going to put these together and these together with a plus sign. What does that look like? Well, it gives me with 3xy over x2, y2 plus 2x squared x2, y2. Great. Then let's put all these together. It gives me 3xy plus 2x squared over x squared, y squared. Yeah, that looks pretty good. Let's go ahead and do that right here. Just we could factor it out too, but let's go ahead and just keep it here. I mean, should I factor it out? Plus 2. There you go. 2 answers. Let's see. Getting a little bit fatigued here. Okay, let's see. We got some stuff going here. Like maybe we can factor this out. Maybe we don't have to. Yeah, let's try to see. Let's try to do that. We have 3x plus 1. I think that's going to work. Then I have 2x x plus 1. Do you see how this is a factoring thing? Okay, perfect. So I rewrote it essentially, right? And so all of this became this. Basically, I just need to put a 3 somewhere here, right? What would that look like? Well, I'll just put a 3 here and a 3 here, right? What does that give me? It gives me 3x plus 1 plus, look at this, 6x, right? 6x, 3x plus 1. And then we have the same bottom, so we're going to put the same tops together, which gives me 7x, 3x plus 1. That's straight up the answer. So all I did was I just factored this out. How did I know that? Well, I was able to predict. That's the thing. I was able to predict that if I pull this out, it's going to look exactly like that. But you don't have to do that. You can put a number here, but the thing is it gets tricky. Like, what do I put a 3 here and then I distribute the 3? You could do that. You could. I mean, then we would end up with this answer. Same thing. Right? But there'd be more steps. There would be more steps because you would have to, well, I mean, I guess it'd just be one more step, but it's more steps. Okay, here's another one. So from the jump, I could tell I'm going to factor that, right? Maybe you don't see it. I do. I see it because it's like this crazy elaborate thing out of nowhere. So let's go ahead and try that. I'm going to rewrite it. 3x squared minus 4. Minus, right? Could do a minus given to us. What can that be? Looks like they're both pluses. For the operator, it's probably going to be a 2. Right? That's what that looks like. But, hey, we can factor that too. We can factor this. So let's go ahead and factor it out. It's a minus. So what does that mean? It's going to look like plus 2x minus 2. There's a video, I believe, that discusses that in my channel. I don't remember what it was titled. I feel like I already told you guys that earlier. Sorry. Can't remember what we talked about. Okay, we factored everything out. How exciting. Ooh, this is super exciting because now look, it kind of looks similar, but oh my God, it's not. We got a plus, we got a minus, we got a plus, we got a plus. Guess what? We have to add stuff to make all the bottoms have the same amount of pluses and the same amount of minuses. That means I'm going to add, let me see if I can change the color. I'm going to add an x plus 2 here. I'm going to add an x minus 2 here. Whatever I do to the top, I gotta do, to the bottom, I gotta do to the top. It's kind of getting wacky, isn't it? So this is all 1 now. And then this is all another with a minus sign. Okay, what does that give me? It gives me 3x. Oh, it gives me 3 and then like the x 2. And then it gives me x plus 2, x minus 2, x plus 2, minus 2x, x minus 2, x plus 2, x minus 2, x plus 2. Now I'm going to, oh no, I'm out of room. And now I'm going to distribute. Right? Let's go back to the top since we're irresponsible here. Okay, let's go to the top. What does that look like when I distribute? Well, it's going to be 6 minus, no, it's 3. Whoops. It's 3 minus 6 over x plus 2, x minus 2, x plus 2. I'm running out of room. I'm going to do a subtraction, and I have an x what does it give me? Squared. Yeah, it's squared minus 4. Well, this is getting really interesting. X plus 2, x minus 2, x plus 2. Now we got the same base. What do? I take this whole top and I put it together, right? So it gives me equal 3 minus 6 minus 20. Oh, it's minus 2x squared minus 4. I think I missed something. Oh no, it's supposed to be right here in x. Chloe. Okay, I messed up. Okay, looking exciting. We can put these together, right? And that would give us a 6. Negative 6, 6. 4, wait, that's an x. Because that would go together. Sorry, everybody. Let's start over here. Okay, so we have 3x, and then we have negative constant, right? And then we have squared, and then we have a variable. Squared variable. Great. This is all correct. All right. Now, let's go ahead and rewrite it. I have negative x squared, which would give me positive 7, right? 3x minus negative 4x is 7 plus 6 all over x plus 2, x minus 2, x plus 2. Yeah, great. This is the final answer right here, this whole thing, because I can't do anything any further. 2x, yeah, I can't factor that out. Yeah, this is the final answer. Kind of got elaborate, huh? So we factored everything out, and then we had to add a whole extra term into both sides, right? Onto both of those little tiny fractions. And then everything in the top was basically just put together. That's our final answer, this little box. I ran out of room. I didn't anticipate all that. Okay, there's one left. One problem left, and then we're done. And oh no, the video's kind of long. I don't even know who's watching this anymore. Same concept. We have 3 different terms now, right? Term, term, term. A term, we know it's terms because they're separated by something called an operator. These are operators, plus, minus, right? These are division, multiplication. We have 3 terms. They all have to look exactly identical. So what would that look like? I'm going to have to put a y and a z in here. Whatever I do to the bottom, I got to do to the top. Plus, should I do different colors for y'all? Okay, let's go ahead and set it up like plus 1 over y plus 1, and then I have z equal sign. Okay. So basically the z has to have the x and the, is that a z? No, it's an x. This is an x. It has to have a y and a z. Y and z. Whatever I do to the bottom, I gotta do to the top. Now I have a y, x and z, x and z from the bottom and the top. Now the z needs the same as everybody else, so I'm going to give it an x and a y, and then it gets a x and a y at the top, because whatever I do to the bottom, I got to do to the top. Now I'm going to multiply these together. What does it give me? It gives me y, z, because that 1 is pretty much invisible, x, y, z, plus x, z, x, y, z, plus x, y, x, y, z. Okay, great. And what does that give me? Well, I have the same base, x, y, z, and then I have y, z plus x, z plus x, y. This is the answer. I can't factor anything out. Do you see how I don't have an x here? So I can't pull out an x. I can't pull out like a y because there's no y here. I can't pull out a z because there's no z here. So I can't factor anything. That means there's no multiple answers. There's just one answer, and it's this guy right here. Okay, so with basically when they're different denominators, you got to do some kind of elaborate moves to figure out how to make the bottom part the same. I kind of ran out of room, so one of the problems were kind of messy, which is a bummer. I hope this video helped. I do have stickers in my sticker shop. Okay, listen, fair warning, I do have some Luigi stickers, okay? So if that's like weird, don't go check out the shop, like if you're not into all that. Okay, thank you everybody. Be safe. Bye.